Okay, so we're moving forward with making Lumina. And this time we are going to start to tackle the problem in just a second. I have to share the wife. So yeah. So now the key idea is to start from somewhere. So we have Lumina here, and the goal is to make it self-moldable. So why is that? Well, because if you're making a moldable development environment, probably the first thing you should start doing is to reach a position where you can develop the product, the development environment inside the development environment itself. This will be the first major milestone, I think. And I discussed this with Cloud, and it seems, and it suggested, well, let's start with the project structure. Basically, let's create a simple project inspector, like we have one here. And probably for now, we will have a simple tree view, and whenever you click on something, you see the code, or maybe not, or maybe you just have a tree view, because I also want to move away from using text as means for understanding code. I'm wondering, can we create Lumina in such a way that text is the last resort, and we rely on medium of communication that's easier to understand than text? So yeah, that seems a good idea. I'll start with making Lumina just render its own file structure as a tree. So how should we do that? Let's see. Okay, this first step sounds good. Let's render. Let's make Lumina display its own directory structure. Let's work in a test-driven development style, right? Failing, or actually in in a test-driven development style. Write an adapter and write suit failing tests that verify the directory listing adapter. It should, in a test-driven development style within hexagonal architecture. It should the directory listing use case. It should receive as parameters. It should have a directory listing function injected, and the function that transforms the listed directories from the adapter to the domain should receive a folder and return the following object. And the object, let's say, should have a name. That's a string. We'll call it, let's say node, because they lack a better name. And then we should say type, which for now is either directory or file. And then we should say children, which is a list of nodes. And that's it. So my goal is to create a framework independent. By the way, you don't see a lot of this because of my video, but I think there's no way to set where my camera is, but I'll keep it in mind. I'll try to show you the relevant code whenever I can. So yeah, we are making it so the business logic receives a file native listing, and then it transforms it to something that can be rendered. So that's the critical thing for now. It seems so. And let's see what it will create. It should be a pretty straightforward transformation. So we have a test here, and of course the business logic in Lumina is in Golang. So we'll start with that first. I haven't used Golang for quite a while, so let's see how easy it will be for me. So it created a comprehensive test suite that covers empty directory, directory with files, nested directory, deep nesting, lister error, path name extraction, and we're injecting the directory lister, the domain types, use case, and the mock directory lister for testing. Good. So let's copy paste this test and let's see, how does Lumina work? We have front end. Okay, let's ask it. Where should I put this test in my current directory structure? So as you can see, I'm already the chat is generating the code for me. Of course, I'll go through the test more carefully to verify that it's sensible. But now I'm more interested not in writing the code, but in finding out where to put it, in understanding the current project so I can use it. So the directory structure is as follows, and let's see, can I list the directory structure? Let's try it that way. I'll just make a screenshot, put it here. Let's see if it will understand it. Okay, so probably didn't understand it, but okay, so we have it, backend, domain, And since you're using Whales, your Go backend code is likely at the root level. Okay, I'll do it at the root level, but I will create, I'll make the directory structure follow a use case approach. So I'll say, the first use case is, let's say, file 3 or directory 3, or actually project 3. And I don't remember, I think Golang didn't enjoy having underscores, so I'll name it project 3 like that, and we'll create a new domain directory here, and we'll create the Golang file. I'm using WebStorm, so, and we'll name it, yeah, directory listing test go. Go files are supported by Golang. Okay. For now, I will I'll just tell Cloud I'll use a use case based approach where each backend directory will denote a use case. I'll put the whole logic inside the project 3 folder at the root of Lumina. And I'll copy that and I'll paste it here. So yeah, it's I'm not sure I agree with this, but I'll just keep it that way. So we have project 3 here, and we have the tests now. And in the tests, we have too much comments. So it says node is the domain object, domain model. So I will put it here. Actually, I'll put everything in the test at first. Directory lister is the port that the adapters must implement. Okay, good. Yeah, it has a list directory. Yeah, this is the port. List directory use case, it's what we'll implement. Mock directory lister, good. And then we have the tests. When we have an empty directory, when we list it, we don't have an error, and we have we should have a no in case of an empty directory. So probably we should actually I'll leave it as is for now. And my next question is, how do I run this? Because as I told you, I lack a lot of Golang knowledge, so I'll just rely straight on the AI. So we'll install the dependencies. The package should be project 3 test. Okay. And we should run the tests. And okay. And we have go mod and go sum, so this will keep track of the files. Okay, let's run. We got stretcher. It changed it installed the dependency in gomod. And now let's see. Run go test project 3. No go files. Go mod tidy. Okay, let's update the modules. It will run the tests. It broke and it says, okay, yeah, not equal. The tests fail. That's good. Great. Let's implement the logic for directory lister. Okay, it creates the domain. It already started breaking stuff into modules. I'm okay with that, even though it's a bit early. File info to nodes. Okay, did some refactoring. I dislike going in such big strides, but let's see what will happen. And it implemented the adapter, which is okay. The adapter isn't something that should be test driven because it's something that we don't control. So let's implement it. So in domain, I will put the first file, which is node.go, and I will copy paste this, and I will save project 3 to the dictionary. If you want. So yeah, we have node. So, and I'll create a directory lister port. Let's name it. I don't like the suffix, but I just want to see passing test for now, and I will refactor later. And inside domain, we'll create also directory listing go, which is the use case itself. And then we'll create the infrastructure, which would be let's say lister go, or maybe lister go. For now it will be simple, and copy paste this as well. Now let's run the test. Actually no, the test should, we should go to the test now, and we should remove all these except for the mock directory lister, and we should import go to lister. Yeah, it's the same, and probably we should import Lumina project 3 here as well. So it maybe domain, or I should just ask fail. Lumina project trees. Okay. How should I import the new files into the test? Aha. Okay, it says it's doing something strange, but let's see. Oh, it created like 5 versions. Okay, so we're in Lumina project 3. Gomod module name. So the module name is Lumina, yeah. Aha, we should use references project 3 dot something. Okay, I'll just copy this test. Let's see what will happen. Lister go package Lumina is not in std lister go. I get these failures when trying to run the tests. My directory structure is Lumina project 3 domain. And here we have directory lister port go, directory listing go, directory listing test go. I should find a way to make this faster, and then we have Lumina project 3 infrastructure lister go. Huh. Okay, I'll do domain. Probably that's that. Okay, and IOFS imported but not used. Okay, and then we have in okay, I'll just do domain, and then we have directory listing test go, package Lumina project 3 is not in. Okay, I'll do domain. That's it. And then we have file info. So file info, it's in directory lister port. So I should do project 3 file info, right? Okay. Yeah. And 120 and 124 and 137 and 170 and 174 and 192 and 196. And then, oops, great. So we have one failing test. It says failed for path. expected project, actual C users projects. Okay, I'll just feed that into the test. Yeah. Into quad. Okay. So, okay, I will do what you say. Of course, this should be the main. And then actually the important logic is in the use case. And I don't think we have anything else to update. Okay, great. Implements a backend directory lister. Great. Now that we have the lister, let's expose it to the UI. Okay, let's go to AppGo. Here we have the method, we have oh, it's moving too fast. Okay. And it doesn't know that I want to use lit and not React, but we will handle that. Of course, that's one of the main issues with LLMs is that they always want to move fast. But I don't want to. So we should include the proper files here. Lumina, we have the app, we have creation of an app, startup, and we have the project tree for a given path and the current project. I'll just use get current project tree for now. Okay, and now Whales generate module. IO lister go course. Wait, let's go step by step. Let's start with the backend binding. We only want to provide a binding for listing your own directory structure. Shouldn't we inject the list? Okay, we have it. Okay, and that's good. I think I get it. We should just import project tree and use project tree infra or file system. Let's see if that will do it. No, we use the no, it's suggesting some seemingly stupid stuff, but let's see. Here is my lister is defined. Is there a chance that I should use a different module name? Also, upgo is outside of project tree. Let's see what it will say. Okay. Ah. Yeah, that's a pity. I think it's I feel really stupid right now. So okay, so the package name should be the same as the folder. Okay, should be domain, 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 and domain. What will happen now? It built. Woohoo! Great, that worked. Wales generate module. Okay. Let's commit. And now, because I really don't know how this thing works, and again, if I had a moldable development environment, probably it would have been integrated so well with the TypeScript ecosystem that I'll be able to inspect this right away. But now I can't. Like, I don't know how I can, like, click here and see a directory structure. So I'll just ask it, good, please implement a really simple lit component that uses the directory listing and displays it. So I just want to see a prototype and to play around with it, and then I'll do it properly. Because currently this component will be really coupled to the source, to lit, and so on. But I want to create a modular code. Let's see. Okay, so create this file in frontend source components. Yeah, I'll stick with what it suggests, and then I'll migrate to a better structure, and I'll call it project 3 TypeScript. I'll add this to Git. The port can be shortened. Okay. No, it can't. And here, it's called domain, so it shouldn't be project 3, it should be domain. Which is, okay, I'll keep it as is, and then let's see, index HTML. I'll just do, no, it's not my element, it's project 3 source, actually it's source components project 3, and I'll just do project 3 here. Let's see, Wales dev. Exit status 2. Render node. Okay, that's good. I like that it's so strict with errors. So it returns any type, but it should return what? A template result. Maybe template result. Okay, that seems good. It builds it. Probably the thing. Oh, good. Wow. And I see it here. So I like that. It's it looks quite well. Of course, nothing more, but I feel good. Wow, that was a really good result. I'm almost tempted to leave it as is, but I want to make things properly engineered. So let's see what we have here and learn from this. So we've created a custom component that's called project 3. It has some basic styling. I don't care about it so much. And I don't know what's this. Probably this, I guess, invoked when the component is added to the document's DOM. Okay, so when we are when the component is in the DOM, we want 3. How do we do it? We use get current project 3, which is bound to the Golang backend. How to expand the root. Oh, cool. That's cool. And then we have a method for toggling a node, and then we have the render method, and we define the tag name. Okay, good. So we're rendering. If it's loading, we show a loading bar. If it's an error, we show an error. If we don't have a tree, we handle that, and then we render a heading, and then we render the node which is a recursive function that just renders HTML. Okay, that's pretty neat. I like it. So, how should we continue here? So I liked the generated code, and it's pretty easy to understand. However, what I don't like is that this is really coupled to lit. So if I want to, like in the directory listing, I decoupled the use case, the actual implementation through lister. I decoupled it, and now I can have a different lister. For example, the current directory lister here is using the file system. So it reads the directory, but in the future I might decide, well, why don't I connect this tool? So, because this is a tool, it seems like an obvious tool, but having a directory listing is a tool in itself. So, and I want to make these tools composable and independent of where they are. And the backend currently is implemented like that. In the future, if I decide to have a different source, like if I host my project in a cloud environment, I can directly start listing uh, directories from, let's say, from the cloud environment or from a different file server or from whatever. I won't have to modify the use case. I'll just have to create a new infrastructure adapter that does listing based on another source, and probably add some logic to uh, to choose a different adapter based on the use case. However, the rendering logic is currently coupling the domain specific business logic. Basically, give me a data structure that's useful for rendering, with the rendering and with the data fetching. So first of all, the first problem I have here is that if I want to use a different project tree retrieval method, like maybe I want to do a web request and use another website, this won't allow me. Like I'll have to refactor this a lot, like change git current project tree and so on and so forth. And also, if I want to render this in another way, so for example, I have the date, I have the directory structure date. So imagine these methods here as foundational. They give me some data, and then I create some tools in my moldable environment to display that data in specific views. Uh, but now the project review is just one. It doesn't give me possibility to modify it, to mold it into what different project needs. So that's why I'd really like to decouple that. First to decouple the tree logic, then to decouple the state. So we have loading error tree, all this state, all this data. I'd like to have a component that I like this component. This is good. Probably I should see if I can spin up Cypress or something and do an integration test just for the happy path here. But still, actually, I can't do it right now because it relies on get current project tree. If this was decoupled, I could inject a fake project tree inside the component and then render it. So yeah, actually, let's start with that. Mm, as much as I don't like this, I would do this. I would remove everything. Okay. Actually, I think I removed too much stuff. Oh no, everything's great. Probably the other stuff was generated by build. Okay, so that's a good POC. Now let's implement it in a hexagonal architecture way using TDD. So first, let's start with the adapter. This adapter with the with the use case, I'll mirror the same logic as we have in the backend. So in the backend we had this. Imagine this is the React component. It uses some kind of a lister. It actually chooses what lister to use, and it passes it to a business logic function that's unaware of what lister we need, and it just returns some data, and then we display this data. In this case, we just display what we receive, but the React component will manipulate it in some manner. We want to do the same on the front end. We want the React component to, not the React, the lead component to create its, to decide what's its data source, then to get the data via the data source, and then to render something based on this data. And the most important thing for us is the data source and what the data source gives us, because there are the business rules that make, let's say, our app unique. So we want to split that out and test it. And then probably I won't set up Cypress right now, but then we just want the lead component to be just a dummy renderer, and that's it. It should receive an injected lister according to an interface and return the data from the lister in a domain object. This should be a really simple test. It's almost unnecessary, but probably later on you'll see how we'll create it in the future. How we'll have more complicated use cases that have some logic and one. So we have the domain type, we have the interface, get current project tree, the use case function, mock project tree lister that returns some data, and then we have the result, and it has empty directory, files, nested structure, and so on. Should propagate errors with rejects should call the lister exactly once. And I see a lot of necessary tests. I mean, it will basically call a function and interpret its result. We don't have to be so. We don't have to have so many tests. These tests are unnecessary. Let's create a single test that verifies that the structure is returned. Also, this use case should notify its user whether it's loading or it has had an error. So basically, this is the generic data. Right now, in the previous implementation, we had the loading state and the error state in lit. Not sure if we'll be able to extract these, but let's see what will actually let's leave that for later. Let's start small. And that's it. So basically we verified that get project tree use case calls the mock lister. And now we can put this inside source, and I'll create here a new directory, which is project tree. And I'll create a use case, or actually the main. I'll follow the same, and we'll create first test file. Yeah, project tree spec ts. We'll have the spec file here, and we'll import the necessary structures. Node, no, this. Now the domain type, we'll add node ts, and this will be the domain type to actually import node from node, and we'll add the project tree lister, which is the interface, and we'll import it as well. And I'll have to fix these, but for the sake of time, and I guess I'll have to install vtest. And project tree lister should like that, and and then we have the use case. So I'll put it here. And now we should install vtest. So now we should have vtest. And let's see. Okay, I should configure vtest. Install writing tests. Scripts test vtest. Okay, good. We have a failing test. And now we should just implement the simple lister. It failed. Why? Lister is not defined because lister should be like that. Oh, we're ready. And now we should implement the lead component that uses the adapter. And here our code is presentation. And I'll create project 3ts. Great, and I'll start copying stuff. No, it's inside the main. It's project 3 lister. So I'll probably have to configure this stuff. We have project 3 lister, get project 3 use case, and then import node from the main node. And the child should be node. And render node should return a template result. And we don't have any issues now. We should create the proper tree lister, adapters. I'll call this infrastructure. I'll create the file here. Whales project 3 being inconsistent. Whales project 3 lister. And project 3 lister should be imported from here. And node should be imported from the main node. Okay, so node, this should be string, okay, because the main node is, yeah, it's, I can live with that for now. And now we have project 3, and in main TS, we don't have main TS. Okay, I'll do main TS. That's where we'll do all of our dependency injection, it seems. Interface project 3 infrastructure, and then we have the query selector, and then in index HTML we have project 3 presentation project 3 TS, and then we have here project 3 Wales dev. Oops. No lister provided. Undefined is not an object. Let's see how it will resolve it. And let's do that. And then we probably don't need index HTML. Oops, I forgot to share the index HTML. Okay, let's see what will happen. Okay, so there seems to be another issue. Let's see the browser. Oh, there aren't any elements. Ah, of course. We should reference it somewhere, no? Okay, that's also strange. Let's see what's the issue now. Okay, and actually I'll just do this throughout, and I get the same error. I get the same error for now. Let's do the dependency injection inside the component. I really want to wrap this up so I have something working for now. So I'll delete main. And here I will import project lister, project 3 actually. And I'll tell it to inject it in index.html. Yeah, great. Script 3 module, type module. And it comes from source project 3 presentation, and then the project 3 itself will be I think. Wells project 3 lister. And we have some issues, so and here we should return template result. And I'll try to rebuild it. Up. Well, it appears here, so always good. It's strange. I should have used that probably. Anyway. So that was the first iteration. Next time we'll see how we're going to continue.